No. I was just commenting that I lost mine, so I bought a new one, and it was 300 ringgits to buy a new one, and then before the new one arrived, someone found my old one upstairs in the office. So now I have two identical styluses, and I asked Aswana, who's got the same computer, whether she'd gotten a stylus, because if she'd already had if she hadn't bought a stylus for it, I would have probably just given her mine, but she'd already bought one. But I was just commenting how expensive these stupid styluses are. 300 ringgits, yeah. They're more expensive in the US, they're actually cheaper here in Malaysia. Because what I was showing here a minute ago on the Amazon site, that if you buy the Microsoft stylus in the US, it's 126 USD. This one here is 96. But if you buy the Microsoft brand, it's actually more in the US than the Microsoft brand is here. That's there. So now the States have got a lot of copycats that are, and you can get through Lazada, you can get the copycats, and that's what I use at home for my desktop computer. I've got at home I've got a large screen that I write on the screen here, up there. But that doesn't take the Microsoft stylus, it takes just a regular capacitive stylus. This one here will take the capacitive stylus, but it doesn't work as well. Up there. Okay, I'm going to get started now that we've got done complaining about the price of styluses. I said I was going to give another assignment on MATLAB only. That there. Well, I lied to you because I was thinking that I had another week of classes, but this is it. This is our last class today. So next week I will be in Bali, but next week's revision week anyway. So plus next week you would have a holiday if even we did, because of the elections Wednesday or Tuesday, and I think they said that they were going to give students Tuesday and Wednesday off, or next Wednesday and Thursday. Yeah. So, but you would have only had 1 week, 1 day of classes. So I put up the final project, and the final project is actually longer than I normally give because I sucked into it the MATLAB project. That there. So when I grade, if there's a grade for the MATLAB project, what I will do is I will use the MATLAB part of the final project as a double grade. Right there. Yeah, I thought okay. That's there. Let me just talk about this. There's three parts to this project right here, and you can submit them as one large Word document, or you can submit them as three individual. I have no way of preventing you from working in groups. I mean, unless I make you do it in class like I did the first one. Since I'm letting you do this on your own, you know, my guess is you'll probably work in groups whether I tell you you can or cannot. That there. So, and I don't really care that much about that, because in real life you will do programming in groups and you will have access to people in your team to do projects. So that there, obviously you don't, my gut feeling is, and take it for what you want, is you're taking this class to get a grade, to get a degree, to get a job. But I'm from the old school, and I'm retiring because I'm old out there, but not actually because I'm old, but because some health issues out there. But in reality, your degree is only worth, in my opinion, what you learn to get it. It's not worth the money you pay for it if you didn't learn anything. That's there. So it's one of those cases that some of you might never write a computer program your entire life, in which case this course was a complete waste of your time and you got your grade to get your degree. Some of you will find 6 months after you graduate, 2 days after you graduate, 3 years after you graduate, all of a sudden you're the departmental or the company computer programmer. So some of you may find yourself working as a computer programmer. My degree is in electrical engineering. That's there. My goal as a student was to work in not power distribution. I was never interested in power distribution, which is the main skew in the department here. But my interest was in RF and radios and cryptology. In a prior lifetime, I was in the Air Force and I worked in military, what they call signal intelligence. We intercepted radio signals from Soviet bloc countries and deciphered them, and this was back during the Cold War, back in the 1970s. So I was really interested in communications and encryption algorithms and things like that, and that's what I wanted to do. So we had a company in my town called Magnavox. They're still there, but they're owned by somebody else now. And we, in Magnavox, and along with ITT Aerospace, built radios for the military, and that's what I wanted to work on, was designing radios for the military. And right after I graduated, I ended up going to work for Magnavox, and I ended up, instead of doing radio work, I ended up writing software in IBM JBL, or batch control language. That's there. And I predominantly have been either an embedded systems or a programming person ever since. And I have never worked in the RF world, even though that was my full intention as a student. And the only reason I'm telling the story is that probably not one of you sitting in this room knows what you're going to do for a career when you graduate. That's there. You don't know. Some of you might end up in this area. Some of you might not. Most of you might not. Some of you might end up working for T&B, working in power distributions as an engineer at either a power generation plant or at a substation or out in the field doing wiring. Some of you might end up working for the Department of Defense, working on military hardware on jet aircraft engines or Navy electronics. Some of you might end up managing a pizza parlor. I hate to say that. We had one gentleman I went to school with ended up owning a chain of pizza restaurants. He had a degree in electrical engineering, decided at some point he didn't like electrical engineering. His family owned a couple of pizza parlors, and he went to work for his family and built 3 or 4 more restaurants there. And I think he ended up owning 3 of the 6 restaurants that the family owned, or something like that. So you really don't know that there. So that's there. So okay, let me just talk a little bit about this final project, and then I'll kind of have some last minute words right there. And I don't know what this thing does. This like that there. The first part of the project is probably the longest part of the project, and that's a C code. I spent more time on C than I did MATLAB. And basically, you are running a restaurant, and you're to write a point of sale program. That's there. Your restaurant sells 6 items right there. I've used this assignment actually in the past. That's there, but that's there you got. So that's there. And a person will walk up to the cash register, and you will put down, they bought a beef burger, a cheeseburger, a hot dog. It totals up the price. That there. You've got some global variables where you keep track of the number of beef burgers sold, number of cheeseburgers, or chicken burgers, cheeseburgers, chicken burgers. hot dogs, French fries, and drinks. So you keep track of however many of each of the 6 items you sold, the total money you collected, along with what the GST you collected for the day. That there, you maintain that. At the end of the day, you will print out a report right there. So this is kind of the order of things. Welcome to Izzy's Fast Western Food. So I call it Izzy's because I own the restaurant that's there. So, you know, there's the list of items. So I enter 1, 1, 3, 5, 6, -1 or 0 to cancel the order. So if you hit a 0, you cancel the order. If you hit -1, you enter the order. So you have to keep track of that there. So once I hit the -1, you reprint the order. The customer ordered a beef burger, cheeseburger, chicken burger, French fries, and a drink, and it cost $10.60, and you collected 60 cents in GST right there. Summary menu at the end of the day. That's there, and again, you get into the summary menu. It says up here, right there. Right there, what's about up there? Up there, the summary menu, right there. Somewhere I tell you how to do it. It's up here somewhere. Each up there, keep track. The order is canceled, not printed on the screen. Okay, well, you have to have an item to, whether I said so or not, you have to have an option there to exit the program. -N. Okay, here you go. And exit the program, go back to the customer routine, or go back without clearing that there. So, but you maintain, you print out at the end of the day, before you exit the program, you will print out the summary right there. 23 cheeseburgers, 23 beef burgers, 19 cheeseburgers, 30 chicken burgers. I sold 10 hot dogs, 40 fries, 43 drinks. So this particular day, I sold 451 ringgits worth of food. Now, I don't know if I made any money on that because I don't know what I paid for the food. 451 ringgits doesn't sound like a huge income for a day, right? That's there. But, yeah, to be honest, I see a guy down the street from me in his front lawn. I live in down Alcota. There, I don't know if any of you are familiar down Alcota, but there's near my house, there's a My Den across the street, and I live in the next subdivision over in a terrace house, and we've got a guy there that in front of his house, he doesn't have any cars parked in his, in his driveway. He opens up his gate and sticks in front of his gate a little rambly food cart, and it's called Zomburgers. I guess it's been around for a while, Zomburger. That's there, and I don't know how many hamburgers he sells every night. He may sell only 23 hamburgers in a night. I keep joking with my wife that that's what I'm going to do when I retire, is I'm going to set up an American-style hot hamburger stand. But I guess Malaysian immigration regulation says that immigrants can't work in the food service industry unless they're brought in by a restaurant. I can own a restaurant, but I can't work in it. So I actually had a brother of mine that always joked when he was in the Marine Corps. I've got a brother who retired from the Marine Corps, and he always joked that he was going to sell hot dogs in Philadelphia as his retirement gig right there, because he ended up retiring from the Marine Corps. He spent 25 years in the Marine Corps. So and he said he was going to sell hot dogs. He ended up not selling hot dogs. His kids all went to college and doing other things. So sat there. One's an electrical engineer, the other's a school teacher. Another one is, actually, I think she's going to work for the FBI up there. Because actually, the same brother actually works for Homeland Security for U.S. Customs. So he's in law enforcement in the U.S. So. But that's problem one. So this is your first problem. This is the hardest one. The second one is relatively simple. I just give you a 3-loop equation. I tell you in the circuit I don't give you a frequency, but I give you the number of the impedance. So that's J4. The capacitor is minus J2. So all I ask you to do is just plug this into a 3x3 matrix and give me the 3 currents. And I think I ask you for the voltage across R3. So you have to multiply the current through R3, and I ask you for the magnitude and phase. And because you have a complex number, you can calculate the phase by just simply using the arctan right there. And you can either give me the phase in radians, or you can give it to me in degrees, but be sure you tell me which one it is right there. So that's a relatively simple problem. And the third problem is even simpler. That's a 1-line problem, or 3-line problem. Plot the function from 0 to 6 pi, right there. So you've got 3 parts of the final. 2 parts are with MATLAB, and I consider them relatively easy problems. Now you might not, when you start doing them, you may not think that they are, but I can tell you that problem 3 is very easy. You know, x is equal to 0, colon, 0.01, colon, 6 times pi. That's there. Y is equal to 2 times sine x plus 3 times cosine 2 times pi. Right there. Plot x comma y. You know. So that's a 3-line problem. You know, I just gave you the answer right there to that one. So that there. Problem 2, I worked in class just before, just last week. So that one is straightforward. Problem 1, that's going to take you a while. So that's there. I worked that there. You've got multiple loops. You've got multiple things going on. That's there. So problem 1 is what is going to take a while. That's there. Now keep in mind that I probably spent 10 weeks on C and about 3 weeks on MATLAB. So the work in the final project kind of reflects that. That's there. And my gut feeling is that if you can program in C, you could program in MATLAB fairly straightforward. Now, the one thing I should point out is looking at FYP papers last week, that there are, was it last Thursday? I think I was looking at the FYP papers, something like that, FYP2. And then I looked at FYP1 earlier. You'll probably use MATLAB more than C in your FYP because there's a tendency in this campus to use MATLAB for any of the research projects you do for FYP. And a lot of that has to do with the fact that there's not a lot of real research lab equipment here. So the only way that you could do any kind of research for an FYP is to use simulation. So you will be using more MATLAB later on. You've had enough MATLAB from this course to kind of wet your teeth, but you'll be digging into the MATLAB books later on to do some things that there. But you are engineering students, and I keep reminding you of that. And an engineer is a person that takes science and applies it to practical problems. Right there. You're not a pure research scientist as an engineer. Most engineers don't do research. unless you get to the PhD master's level. At the bachelor's degree level, you're an applications engineer, right there. And you're going to be looking at research journals and reading them and kind of understanding what the current science is, and then you have to apply it to existing problems. Right there. Probably 75% of what engineers do that I have worked with, and I will point this out from a U.S. perspective more than a Malaysian perspective, is that I look at an existing project and I realize that we need to move it to the next level, we need to make changes, we need to come up with this year's model, and so we have to understand last year's and make updates and changes to it. Use new technology that has come up in the last year or so. Out there. A lot of the projects I work with are embedded systems that use microcontrollers or microprocessors. And you know, an example is MP3 players have been around for a long time. You know, the first MP3 player that I use was put out by a company called iRiver, and it played CDs that were recorded in MP3 format, right there. It didn't play from a solid state memory like the modern ones do. So that there, the next year's models came out. They also played from CDs. That there, they would play DVDs, which would hold a lot more music because the DVD readers became smaller and small enough to fit in the package, and the drive was a little bit smaller. And then the following year, they started to come up with dedicated MP3 players. SanDisk was one of the earlier ones that would play, MP3s that were stored in solid state memory. SanDisk is a big memory producer, so they came up with the early one. That a little bit later on, Apple came up with the iPod, which was a copy of the SanDisk player, essentially. The early iPods were copies of the SanDisk players. And then they came up with the iPhone later on, which will also play music. And then the iPod Touch was essentially an iPhone without the phone. And that sounds like a strange thing to say. But as you can see, there's a progression of these products that are being developed. iPhone didn't sit down and came up with the iPhone off the top of its head. The iPhone combined the iPod, which played music, and along with a phone, which was really a copy of the BlackBerry, which was a Canadian phone company, the BlackBerry. And the Palm Pilot was also an early version of the BlackBerry or the iPod Touch that it played music and it had out there. So there was lots of these products that were being developed, and Apple was always kind of a copycat behind that there. So, but a lot of the engineering work that I've always worked at has always been not pure research in the fact that we're going to sit down and invent the latest, greatest thing. That there, it's always been updates of previous, even the military work. I worked on sonobuoys, and sonobuoys is something you drop in the ocean to look for submarines. Right there, it has an underwater microphone. It has a lot of signal processing hardware in it, a lot of microprocessors, a lot of that there, and sonobuoys have been existed for a long time. I mean, submarines have been fitted with little tips on the end that listen for other submarines as they go through the ocean. That there, submarine warfare has been around since World War II. The German U-2 boats are quite famous if you ever study World War II, and the British came up with ways of looking for U-2 boats using acoustics, listening for these boats underwater, right there. So a lot of this type of stuff that there is, some of it leading edge in research. Oh, by all means, the next generation is something that hasn't been done before. In Malaysia, as engineers, most likely you're going to be involved in manufacturing and not necessarily design work. That they're simply because design work requires a lot of money up front, and I won't talk about the money that I've thrown away as a design engineer on designs that didn't work. I probably have thrown more money away than my salary over some of the years that I worked on projects that just flat out didn't work. Then I've had projects that I worked on that worked beautifully, and because of management decisions or because budgetary decisions were thrown in the trash right there. So worked on a project. I was not the lead engineer. I was just kind of peripheral. I wrote some software. But there was a project done for the Army back, this was in the mid-'80s, early '80s. They called it Sergeant York out there. But it was an anti-tank weapon right there. And it was one of the early types of weapons where you fired what they call a laser-guided missile at a tank, and you had to hold the weapon on the tank. Worked beautifully. Worked beautifully. It blew up tanks. And that's what it was designed to do, is blow up tanks. The only problem with it is that in order for the projectile to hit the tank, and I'm trying to think of the right word, but the bullet or the shell to hit the tank, the operator had to keep the laser on the tank, which means that he had to stand up from his foxhole or his hole in the ground or from behind the hill, stand up there and is holding this thing, pointing it at the tank. So if you could shoot the operator before the missile hit the tank, the missile would always hit the tank. So when they tried it out in testing, they realized that they're going to lose a lot of anti-tank gunners if they build this thing, put it out in the field. Because as soon as they fired that thing, whoever's tank that was being fired upon would turn their gun around and shoot the tank, the gunner, because that's how you defeated the weapon. So obviously we spent millions of dollars, not on my salary, but in the whole company on this project, and I do mean millions and millions of dollars. And to have the whole project just scrapped the first time it was tried in a testing operation right there. So that's why R&D in particular is very expensive, because you throw away a lot of work. Now, some of it you learn from. You learn from your mistakes. Obviously, the Army learned from the mistake and never developed such a weapon again. But even things that I worked for the private sector ended up become obsolete by the time we built it. I worked on a project one time called Sun Tracker. This was like a big parabolic dish that created solar energy, and the whole idea was that it would optimize the amount of sunlight that would hit on it. That's why it was called Sun Tracker. Well, we got the thing built and only to discover that, somebody else built one twice as good, at half the price by the time we were ready to hit the market with it. So obviously we threw away a couple $100,000 worth of research because we weren't fast enough and we weren't good enough to beat our competition. That's there. And that's the problem with research and development type work and developing new products, is that you're competing against people that have more resources, have more money, have more experience, and That they're now, of course, the only way you get the research and the experience is you make mistakes, but mistakes are expensive. So as a result, I haven't seen a lot of R&D work done outside the universities here, and even then I don't see a lot out there. Okay, back to, that was a little bit of my soapbox that there. This project I put up on, it should be the very top thing in the VLE, and I gave it a due date of 1 week from Monday, so you got about a week and a half to do that with. Don't wait till next weekend, because I can guarantee you that part 1 is probably going to take 75% of your time. Part 2 should take probably an hour or so, and part 3 should take probably all of 20 minutes. That's there. So the grading's probably going to be, I'll tell you right off, 50% on part 1 and 25% on each part B and C right there. I didn't put that in on the final exam. I will probably repeat the grade if there's a place on the grade sheet for the MATLAB assignment. I'll use part B and C for that, because I'm going to count that as both part of your final grade or final project and the MATLAB that there. But the MATLAB parts are fairly straightforward. I mean, that's there. If you can't do a quick search on the internet and find the answers in 30 minutes for both of those, I don't know what I'm going to tell you. Part 1 is going to take you some time. That's all I have for everybody. That there. So it's been a fun course. You've been a great group of students. The one thing I will say about students here is that you're a whole lot more polite than some of the students I've had back in the U.S. You're a whole lot. You're very friendly. American students sometimes can be quite rude. Trust me. That there. American children can be rude. That there. Even as adults, it can be rude. That there. So, but. We've actually had some students that have had some of our faculty members in tears after a few weeks. We've had some problems that, in particular, we had a woman that didn't have any work experience, and she was teaching a night class where everybody was working for ITT, Magnavox, or Bomar, or GE, or somebody full-time during the day and going to school part-time. So these students had a lot more hands-on experience than the faculty member. And this particular faculty member took the attitude that I'm the PhD, I'm the expert, and you people don't know anything. And unfortunately, these students basically ate her for breakfast as far as the way they treated her. I mean, they were pretty cruel. And the problem is that the students knew more than she did. I have had classes where I've had students know more than I do. I taught a course early in my career where I had an older gentleman. He was probably, I'm going to say an older gentleman, he was probably my age now at that time. I was in my late 20s and he was in his early 60s. And he worked for General Electric designing motors for washing machines and dryers. And I was teaching a machine on generators and motors. And I've never designed a generator or motor in my life at that point. Had no desire to design a generator or motor in my life. That was not my area. That was not what I wanted to do. But this guy had been doing it for 40 years. And he was taking my class on motors out there. Obviously, he could have really made me look stupid. It would have been no problem for him to make me look stupid. In comparison to him, I was very stupid when it came to motors and generators. We got along great. And the way we got along is I admitted that I didn't know anything right off the bat. I asked him for help from time to time, and it was very productive. But in this particular case, this woman did not admit she didn't know some of these things, and that's there. I've taught courses that have been my area. I've taught courses in VHDL, for example, which is the Visic hardware design language for microprocessors. I'd done multiple projects in VHDL, and I knew VHD very well. I had a student in my class that worked in Magnavox full time for 10, 15 years doing VHDL designs for the military on classified projects, who knew it much better than I did, because that's what he did 8 hours a day for 10 years. That's there. Again, we got along fine because that's there. And you'll find the same thing when you go out to work. You'll have a degree in engineering, and you'll have some technician working with you who knows 3 times as much as you do. Admit that this technician knows more than you do, and use them to learn that there. I've had technicians that have worked for me that made me look very, very good because I got along with them well. I used their knowledge. I didn't take credit for it as my own, but they let me take credit for it because I was the project manager and they were the technicians. But I had technicians that were probably better engineers than I were at the time. So just keep that in mind as when you graduate and you're out there in industry and you're around people such as technicians or even people without degrees that have been working in that particular industry for a long time, but they may know more than you do. They may be paid less than you do, than you're being paid, but they're more knowledgeable, and you just have to accept that there. So with that said, it's been a pleasure working with everybody. I will not be here next week, so if you've got questions on the project, I will be checking my email. I will have my laptop with me. That's there. It's kind of a squirrely situation. I was supposed to meet my son in Bali. He ended up canceling, but I had already bought plane tickets, so my wife and I decided we're going to go anyway. But I'll be out of town from Monday through Thursday. So over the weekend, I'll be here. I can answer any questions. Another reason to look at it over the weekend. Before the weekend, this is what, Thursday, so for Wednesday. So you've got some days between now and Monday before I leave, so will be able to ask questions. I will be back next Thursday, so I can answer any questions. If need be, I can come in on next Friday to meet with everyone, with people if you've got questions. And I'll be back next weekend at there. But Monday through Thursday of next week, don't expect a whole lot of help from me. All right, thank you very much. And I may not see some of you again.